Today's lesson is 11.6, comparing fractions. The objective for today is that I will compare fractions with unlike denominators. Quick reminder that we call the denominator is the bottom number in a fraction and the top number is the numerator. First thing I want you to include in your notes is the definition of a benchmark fraction. A benchmark fraction is a fraction that is easy to visualize and use. So when we think of 1/2 and 1/4, those are two benchmark fractions that are most commonly used. They are benchmark fractions because if I told you that right here is a chocolate chip cookie and you get 1/2 of it, all of you would probably go ahead and quickly visualize the part that you would get. If I told you that you would get 1/4 of this, you probably could also visualize that you could get just 1/4 of that cookie. Those are benchmark fractions because, again, they are commonly used. The first problem we're going to take a look at today says, Emily read for 5/6 of an hour, Shannon read for 1/3 of an hour. Without writing anything or using fraction strips, can you tell who read for a longer period of time? Well, since we're doing this as a video and I want you to write some stuff down, I want you to go ahead and write down the fractions from the problem. You don't have to write down the entire problem, but let's use 5/6 and 1/3. We're going to use 1/2 as our benchmark fraction. So what we're really doing is we are trying to compare both 5/6 and 1/3 to 1/2 to help us understand which one would be a greater amount of time. So 5/6 of an hour compared to 1/2 of an hour, we know that 5/6 would be greater than 1/2. The reason we know this is if we thought about it on a number line and we had 5/6, would mean I'd have 0 and I'd count out for 6 total. I'd go 1, 2, 3, 4, 5, 6. This spot right here would show me 6, 6. And this spot, which I'll do in a different color, will show me 5, 6. So on this number line, there would be 5, 6. If I wanted to plot 1/2 on this number line, I would need to think about what out of 6 is a half. Well, I know that 3/6 would be equal to 1/2. So 1, 2, 3, this would be 3/6 or 1/2. So I can tell based on this number line that 5/6 is greater than 1/2. Again, I'm drawing these visuals for you, but some of you would go ahead and visualize that in your head to know that 5/6 would be greater than 1/2. The other idea is that 1/2 or 1/3 is less than 1/2. Again, a good way to do that would be to have it on our number line. Because we've already worked with equivalent fractions, we know that we can take our fraction 1/3 and have a new denominator of 6 to figure out what fraction is equivalent so that I could also plot 1/3 on my number line over here. Well, 3 times 2 would give me 6, so whatever I do the bottom, I have to do the top. So 1 times 2 would be 2. So it would be 2, 6. So this spot right here, which would be 2, 6, would be equivalent to 1/3, which shows me that 1/3 is less than the 1/2 that I have right here. So ultimately, I would figure out that Emily, who read for 5/6 of an hour, read for a longer period of time than Shannon, who read for 1/3 of an hour. Using equivalent fractions, we can come up with the simplest way to be able to compare our fractions. The benchmark fraction is a fraction that's easy to visualize, like we've already talked about. Many of the common ones, like I already said, were 1/2 and 1/4. 1/3 and 3/4 are also used pretty commonly, but 2/3 is used frequently, but not as much as 1/2 and 1/4. In your notes, we're going to do a couple problems together. So I want you to write down number 1. We're going to do all 4 of these. We'll do 1 and 2 together, and then I want you to try 3 and 4 on your own. So the first thing that we're always trying to do is trying to find a common denominator between the two fractions. So what I'm going to do is I'm going to take a look at my denominators. So on number 1, you should have 3/4 and 6/8 written down. Well, I have to take a look at my denominators, like I said. I look at 4 and 8. I need to find the multiples of both 4 and 8 and figure out what their least common multiple is. So what I would do is I would write 4, and I start listing out the multiples of 4. So 4, 8, 12, 16. I'm just going to stop right there for now. And then I go to 8. For 8, I'll go 8, 16, and I'm going to stop because you know when to stop when you have one number that is the same in both of the two. So I see right here that 8 is the same. It means I want to change both my fractions to have the same denominator. That is the easiest way to be able to compare the two fractions. Well, 6/8 already has 8 as a denominator, so all I have to do here is I need to take 3/4 and write the equivalent fraction for 3/4 with 8 as the denominator. So, what do I have to do to 4 to make it become an 8? It's getting bigger, so I know it has to be multiplication. 4 times 2 is 8. Whatever I do the bottom, I have to do the top. 3 times 2 is 6, so I have 6/8. Well, if I look here, what I'd be doing is I would replace 3/4 with 6/8, and they are equal. It seems complicated because there's multiple steps, but if you take it one step at a time, I know you're going to get it. So let's take a look at 1/4 and 1/10. I'm going to go to a new page, but I still want you to write these down. 1/4 blank 1/10. This is number 2. Now on your paper, I want you doing this work with me because we have to list out the multiples of both 4 and 10 to figure out what their common multiple is. So I start with my 4. So again, we'll do 4, 8, 12, 16, 20. I'm going to stop there for now because if it's a multiple of 10, I know that it has to end in a 0. So more than likely, 20 is a common multiple here. So I've got 10 and 20. So I find my common multiple. Now on this one, I have to change both fractions. So it's going to look a little bit different than our first problem. So the first thing I would do is I would change 1/4 to a new fraction with a denominator of 20. Whatever I do to the bottom, I have to do to the top. So 4 times 5 equals 20, and 1 times 5 equals 5. So 1/4 is equal to 5/20. Now again, my denominators have to be the same to be able to compare them. So I have to change 1/10 to something over 20th. So what times 10 equals 20? 2. So whatever I do at the bottom, I have to do the top. 1 times 2 equals 2. So I look at 5/20 blank 2/20. Now, if the denominators are the same, like they are here, all I have to do is compare the top two numbers. Well, a 5 is bigger than a 2, so I automatically know that 5/20 is greater than 2/20. In your notes, I would like for you to try doing number 3 and number 4 and have them ready to go.